Hello, my name is Alex.
I'm Ryan.
I'm Caleb.
And I'm Cooper.
We are the current team leads of Velovations Enterprise. Velovations is a bicycle-focused enterprise comprised of a group of students dedicated to combining our love for bicycles with their engineering abilities to create new components and accessories for the biking community. This year, Velovations is busy working on 4 different projects. The Hub and Trailblazers are sponsored task projects, while ABBA and Heated Grips teams are internally conceptualized their own projects. To start, we'll dive more into the Hub team.
Voodoo Hub was created 3 years ago when a tech alumni reached out to Enterprise for help. This year, our team is made up of 5 mechanical engineering majors, including myself, Nick, Jack, Hayden, and Carter. We work with our sponsors, Tony Sanger, who started Sanger Innovations. Sanger Innovations has a patented clutch hub design that needs some fine-tuning in order to someday get to market. A new take on the traditional bicycle hub, Voodoo Hub is aimed at being silent and frictionless. This design could have many applications to be used simply as a clutch, like in a helicopter blade or motorcycle. The end goal for Sanger Innovations is to create a real bicycle hub that is competitively priced in the high-end bicycle hub market, with near instant engagement and zero friction. This would target cyclists in competitive mountain and road biking. Achieving this goal is a long process, and we have been happy to help along the way. This past year, our team has worked on further developing different testing methods for bicycle hub with drag, life cycle, and sound testing, as well as computational models for the dynamics of the hub. This has included a lot of research in components, learning how to develop code to run tests, and many different design changes to accommodate for the high loads during life cycle testing. Our members have also focused on dialing proper sound testing procedures to reduce resonances and variables to isolate sounds produced by the hub. We are looking forward to continuing to help Sanger Innovations by conducting more validation testing and computational models to make sure this product gets to market. The future scope of this project is to have a fully functioning prototype by next year with the help of MATLAB dynamic models, advanced machining, and tolerancing. This upcoming year will focus on refining the product and putting it up against some of the high-performance hubs already on the market. Following testing, the team will improve upon design, get ready for rider testing, and manufacturing for the market.
The Trailblazer team was formed this year. Starting over the summer of 2023, we began this project by completing customer discovery interviews with local UP trail builders in order to identify common issues that contractors often encounter in search of an engineering product and solution which would be later suitable to bring to market. Identifying the issues that often arise is transportation and mobility of essential components such as tools and fuel. From this issue set, it allowed us to focus our sights on designing a trailer for deep forest trail building. The Trailblazer team today includes 5 mechanical engineers, myself, Logan, Lewis, and Caitlin, who share a goal of creating a maneuverable, durable, and easy to maintain bike trailer. With commercial bike trailers often designed solely for road usage, utilizing only a singular wheel with small body frames, they often lack trail mobility and adequate storage space, while also costing between $400 and $800. The goal of the Trailblazer team is to capitalize on the trail building market with a cheap and reliable product targeting the labor market who will be able to benefit from our project. By the end of the 2023 semester, the team had developed a theoretical CAD prototype. However, throughout the semester, our team focused on a series of challenges due to a lack of efficient design experience, which would prove to be a rather large learning curve. As a result, our designs would often be faulty or be unable to manufacture. To counteract this issue, our team would reach out to both university faculty and our advisors at General Motors for feedback and advice, while also completing internal design reviews, allowing us to review each other's work and identify potential issues before we manufactured. This spring semester, the Trailblazer team focused our attention from research and development to manufacturing proposed design. This in turn will see us completing engineering drawings, allowing us to machine necessary parts. However, this shift in focus would generate some problems for our team, as not every part was feasible to manufacture within the Michigan Tech facilities. One such example is represented in our initial proposed idea for our trailer's frame, which was supposed to have 2 90-degree bends in order to create a bent frame. However, we realized no machine at the university or any local manufacturer would be able to produce such bends. As a result, we needed to redesign our prototype to be composed of 2 45-degree cuts instead. This would prove to be a satisfactory result. As of finals week, in the spring semester, the Trailblazer team has fully machined every component present within the prototype models and have shifted our focus to completing the weldment of the trailer frame with a final product expected by Design Expo. The Trailblazer team has no shortage of future work to undertake. Starting off next fall semester, our team plans on completing rider testing at Michigan Tech trails to determine how well the trailer handles and possible adjustments that would need to be made. This will entail riding on cross-country and downhill trails with some parking lot testing to determine how well the trailer handles. For their work will include researching material change from our current standard bike steel to aluminum in order to reduce overall weight, while also researching tensile testing and other joint connection methods.
Our third enterprise team, composed of mechanical engineering majors Ben, David, and Cooper, is tackling a common frustration for cyclists and bike mechanics: messy and time-consuming hydraulic brake bleeds. Enter ABBA, their innovative solution that automates this process. Most modern bikes rely on hydraulic brakes, offering fantastic performance. However, bleeding them can be a nightmare for both professional mechanics and home enthusiasts. ABBA solves this by automating this process, making it quick, clean, and user-friendly. This portable, battery-powered device utilizes clever peristaltic pump. It gently pushes fresh fluid through your brakes, eliminating air bubbles and ensuring optimal performance. Connection is simple, just attach the hoses to the bleed ports and press the start button to go. ABBA utilizes a pre-programmed cycle time of around 35 seconds and a float switch to deliver the perfect amount of fluid automatically. No more mess, spills, or wasted time. ABBA isn't picky about brakes. It's designed to handle a wide range of brakes and fluid types, adapting to various brake bleed procedures. The compact design even mounts conveniently to your bike's handlebars for an easy operation in any workspace. To further enhance the functionality, the team is exploring features like retractable bleed lines and compressed air purging. Bike shops can significantly boost service efficiency with ABBA, while home mechanics can finally perform high-quality brake bleeds with confidence. Say goodbye to frustration, hello to clean, user-friendly brake maintenance. This exciting project is well underway with a successful prototype. Future iterations will focus on optimizing bleed times, minimizing fluid waste, and ensuring long-lasting performance through hose lifecycle testing. Stay tuned as ABBA continues to evolve and revolutionize the way cyclists maintain their bikes.
The fourth and final Velovation team is Heated Grips, or Hot Paws. The team includes Ryan, who develops the mechanical parts, and Jack, who develops the electrical components of the grip. The goal of this student-ideated project is to create heated bicycle grips that are powered by rechargeable batteries, allowing the user to extend their riding season into the colder months. This is achieved by placing the battery and electrical components in a center core that slides and locks into the handlebars, creating an electrical contact with the heated elements in the grip. During the fall semester, the team continued innovation of the existing prototype, starting with trouble releasing the grip from the 3D printed mold that was previously used creating the grip. The diamond pattern of the grip caused perpendicular release angles between the grip and the mold. To alleviate this, the team switched to a silicone mold, allowing for parallel release angles for all parts of the grip, which was assisted by the use of mold release. Additionally, the team innovated on the printed circuit board, or PCB, that they had previously created to allow the most power into the grip while minimizing the size of the board. Finally, the team finished the semester by beginning sizing of the central core using a small puck for general tolerances and dimensioning. The dimensioning was completed in the spring of 2024, allowing for the continuation of the CAD of the core. Spaces for the batteries and the circuit board were added, as well as a hole on the end for the USB charging cable. The PCB was also updated after it struggled to handle power requirements. Using a boost converter, the PCB was able to output more power and properly heat the grip. Finally, the functionality of the PCB was tested, ensuring a working grip for differing temperatures, and the LED correctly indicates the different power levels and battery status. The future of this project will take Hot Paws in different directions than before. The completion of a fully operational prototype will see slight improvements in the design, including design changes for ease of manufacturing. Yet the biggest next step will be reaching out to component companies to see if they would like to help continue this project to the market. All members of Hot Paws are graduating this spring, so the continuation of this project will be decided by future members of Velovations. Hot Paws' working prototype offers a comfortable grip for year-round commuters, and they hope others will be able to enjoy warm hands while biking. Velovations is an enterprise open to exploring any project that revolve around biking. We are proud of the work this year's 4 teams have done, and we look forward to what the future of Velovations has to offer. We look forward to seeing and speaking with all of you at Design Expo. Thank you for taking the time to learn more about what we do here at Velovations.